So now that we know what like terms and unlike terms are, now we're going to actually talk about adding and subtracting polynomials, okay? So if you look at this one down here, we have 1, 2, 3 terms, that's a trinomial. Subtract another trinomial, 1, 2, 3, okay? So we're going to have trinomials with other trinomials. Or in this case, we have one term, mononomial, subtracted by a binomial. See how they're using parentheses to separate the different polynomials? They're using set of parentheses to separate the mononomial from the binomial, or the trinomial from the other trinomial. What we're going to try to do is we're going to look through this whole problem to see if there's any like terms that we can combine. So what are the steps to add and subtract polynomials? Well, let's look over at our steps. Okay. So our first step says to remove parentheses, because these problems will usually have parentheses. What we're going to do is we're going to distribute any outside coefficient and its sign. Remember, if you don't see an outside coefficient, there's always an understood 1. Once you get rid of the parentheses, then what you're going to do is we're going to look for like terms. Kind of group them by circling or underlining so that you know what like terms will go with each other. Remember, like terms have the same variable parts. That means you have to have the same variable and, not coefficient, exponents. Okay, so make sure it has the same variable and exponents. Then what you're going to do is you're going to combine like terms. Remember, we said once we know which ones go together, you're going to keep the same variable part. That means keep the same variable and exponents, but then combine the coefficients using the tug of war. Remember, 2 of the same labels you add, 2 different labels you subtract, and then ask yourself who wins the tug of war game, who has the most players. Once you do that, then what we're going to do is arrange our answer in descending order. What do I mean by descending order? You want your exponents to be going downhill. So that means if you have an x cubed and an x squared, you're going to do x cubed first. You want the 3 exponent first, then the squared exponent, and you're going to use the constant term last. Okay? If there's more than one ladder, then you're just going to go alphabetical. So if you have AB and then A squared and then a B squared, the A terms go first in descending order. We'll look at this a little bit more once we get to more complicated problems. The first problem that I have here is, notice that we have a set of parentheses. So when you have a set of parentheses, we need to remove it. Now, we were doing the power rule before. Remember, if there was an exponent on the outside, we were distributing. But the power rule only works if this is a mononomial. See how this is 2 terms? 1, 2. Because it's 2 terms, we're not doing power rules at all. So how did we remove parentheses? Remember back in Unit 1, if we had a set of parentheses, I said, look to see if there's an outside number. If you don't see an outside number, then there's an understood 1. So notice I'm going to put that understood 1 here. Okay? And then what you're going to do is distribute the number and its sign. Distribute means that we multiply. Remember, this is not the power rule where I only have to worry about distributing to only exponents. This is going back to Unit 1 material. Again, this is not power rule because 1, you don't see an exponent, and 2, these are trinomials or binomials, not mononomials. So no power rules here. So when I distribute -1 times 20m to the 4th, just multiply these 2 coefficients. You're going to get -20 and then keep m to the 4th. And then -1 times positive 17m is going to be -17m. Because -1 times positive 17 is -17. Keep the same variable, m. Now because this is on the outside, just bring it down. Notice we do not have any parentheses. So now that we have no parentheses, we can see if we have any like terms. Remember, like terms, look at the variable part. The variable part here is n to the fourth. Variable part here, n to the fourth. The variable part here, m. So which ones match each other? This and this. Notice when I circled not only the coefficient, but its sign as well, because that helps me collect like terms. So all I want to do now is say n to the fourth, n to the fourth. Remember, they're like because they have the same variable and exponent. And I can collect them by just saying n to the fourth stays n to the fourth. All I'm going to do is use my tug of war to combine my coefficients. This is a positive, this is a negative, and when you have a positive and you have a negative, you know that you're going to subtract. Who wins the tug of war? 25 players or 20? Team 25. So that's why team positive will win. And then since there's no other n to the fourths, we just have an m, remember, to the first power. Since they don't match, just bring it down. This is considered simplified. The reason why is because you don't have any more like terms. We took something that originally had 3 terms and condensed it down to 2. Sometimes you can condense it even smaller, but sometimes you might not have any like terms, where it means it can't be simplified any further. Let's take a look at the second guy down there. Notice we have a set of parentheses here and here. So remember, because this is a trinomial, how do I know this is a trinomial? 1, there's the separation, 2, there's the separation, 3. 1, 2, 3, trinomial. 1, 2, 3. You're not doing any power rules here because we have trinomials, not monomials. So to get rid of these set of parentheses, you have to distribute the outside coefficient and its sign. If you don't see one, slip in a 1. So we're going to distribute the 1 and its sign, negative, to all terms inside here. Notice here there's no coefficient, so we're going to slip in that 1. So we're going to distribute a positive 1 here. So 1 times 5s squared, 5s squared. Doesn't really change anything. 1 times negative 6st minus 6st. And then 1 times negative 3t squared, still negative 3t squared. When I distribute a negative 1 here, negative times positive makes it a negative 2s squared. Negative 1 times positive will make it a negative 1st. Negative 1 times positive 2 will make it a negative 1t squared. Now some people say, why did you put the 1s here? It makes it easier for me when I start collecting coefficient with coefficient. So that's why I put the 1 here, because it's 1 times negative 1 gives you negative 1. 1 times negative 1 gives you negative 1. Okay? That will help you. Once we get rid of all the set of parentheses, then we told you we can start collecting like terms. Now this one's a little harder to collect because this one has s's and t's. Don't let that bother you too much. You're just looking to see which ones have the same matching variable part. It doesn't matter if it has 2 letters or 1 letter, you're just looking like a puzzle to see what pieces match. So we know an s squared can collect with another s squared. See how they have the same variable part? And make sure you include the sign. So I'll make this a little bit bigger. What else are like terms? This guy with this guy. I made that circle a little too much. Oops, wait for that. See how they have st as the variable part? St as the variable part? Huh? And then the next one, this and this. maybe I should just underline it. Okay? Just so that I know that these two match, and these two match. But this won't match with this or with this. They all match only to a certain fellow. Once we know which ones are the like terms, we can label this and this. We have a positive and a negative. So, different signs. We're going to subtract. Who wins the tug of war? 5 versus a negative 2. 5 has more players, so it's going to be a positive. S squared. Remember, I told you, this stays the same variable part. Don't make it s to the 4th. 5 widgets, take away 2 widgets, means we have 3 widgets. Keep the same label. Then, this and this can go together. This is a negative. This is a negative. So when you have 2 negatives, remember, same labels, we add. 6 and 1 means 7. Who wins the tug of war? 6 players or 1 player? Team 6. Keep the same label. ST, ST, ST. And finally, this with this. Again, this is a negative. This is a negative. So again, adding and subtracting is more about tug of war. Sometimes I'm going to subtract things, sometimes I'm going to add. Because these labels match, add. 3 and 1 is 4. Who wins the tug of war? 3 players or 1 player? Team 3, so team negative. T squared stays T squared. Now, is this the correct order? Remember, we want this to be in descending order, so start with your biggest exponent first. But notice we have S's and we have T's. So notice I start with S first, alphabetical, make the S's go downhill. So S to the second, S to the first. So that's why this went first, this goes second, and then since there's no more S's, we can go to the next letter, T, and the highest exponent with T is square. This gets a little tricky, so if you have it in a different order, I'm pretty sure Alex will accept it, but they usually want this to be written in what we call descending order, alphabetical order. Start with the alphabet, S, start with the highest exponent, we call this a degree, and let it go downhill. So S to the second, S to the first. Once you're done with S's, go to the next letter, T. Then you go with U until you run out of letters. Constant term will always go last if you have it.